So you may be wondering what exactly is going on here.
Well, of course, it's volumes of revolution.
Volumes of revolution are a three-dimensional figure of a 2D graph that is rotated about one of the axes.
There are two different types of volumes of revolution. First, and the most simple, are the disks. Disks are essentially when there is no hole within the three-dimensional solid that is formed by the function.
So let's look at an example. Let's say we have a graph f of x equals bottoms, or more commonly known as f of x equals the square root of x.
If this graph were to revolve around the x-axis, a disk would be formed. To find the volume of this shape, all you have to do is memorize this basic formula.
So let's plug in some numbers to our equation. We know that r is the square root of x because that's our given line. We're going to set our limits 0 and 25 because that's what the problem calls for. So we plug in these numbers to our integral and we get a final answer of 625 pi over 2. Moving on to the other type of volume of revolution, the washer. These are a little more complicated, as you can see by this formula.
For this type of volume, there are two graphs. Our goal is to find the volume enclosed between the two graphs when they rotate.
If Ms. Procell is the graph f of x is equal to the square root of x, and Mr. Medlin is f of x equals 1/5 x, we subtract Medlin squared from Procell squared.
And then we integrate that expression from 0 to 25 and multiply the whole thing by pi.
So let's start by plugging in numbers. Since our limits are 0 and 25, this is where the graphs intersect. Then, since big R is square root of x, we'll plug that in there, and 1/5 x is little r. Once we integrate, we can put the limit down again, and then solve by plugging in. Simple as that.
So, after taking our integral, we get a final volume of 104.1667 pi. Thanks for watching!
Baby, let's go!